Your grandmother never used herbicides. Not because she couldn't afford them, because she had 4 plants growing at the edge of her garden that handled it for her. Science just spent decades figuring out why they worked, and honestly, the answer surprised me. Every spring, Americans spend over $1 billion on herbicides. Let that number land for a second. $1 billion. A significant part of that goes toward killing mugwort and wormwood, the exact same plants that Appalachian farmers and Eastern European gardeners carefully protected for generations. Not out of sentiment, out of hard-won strategy. Today, I'm going to show you 4 plants most gardeners pull on site. And plant number 4, the one in every nursery for $2, actually kills the worms that destroy your tomatoes from underground. Most people plant it for the flowers and never know. I'm going to walk you through the chemistry that makes each one more valuable than almost anything you'd pay for at a nursery. This isn't folklore, it's evolutionary chemistry. These plants survived for centuries without anyone's help. The defense systems they built to do that, the chemical compounds, the soil chemistry, the root exudates, those systems still work, and your garden can use them right now. I've gone through the peer-reviewed research and the university extension studies, so you don't have to. Every claim in this video has a source. No folklore, no guesswork. The chemistry on these 4 plants is documented in patents, in journals, in university extension programs that have been testing them for decades. Here's the bigger picture, before we get into the individual plants. Most ornamental plants you find at a garden center were selected for looks. Breeders optimized for flower size, color, bloom time. In doing that, they often reduced essential oil content, the very compounds that give wild plants their defensive chemistry. The plants we call weeds never went through that selection process. They stayed wild. Their chemistry stayed intact. That's not a romantic idea. It's what the compositional research on wild-type Artemisia plants consistently shows. 4 plants, 4 different defense mechanisms. Let's go through them one by one. Plant number 1, mugwort. If you've ever seen a tall, bushy plant with silver-green leaves that smells sharp and medicinal when you brush against it, that's mugwort. Artemisia vulgaris. It grows 3 to 6 feet tall. It spreads fast. And if you've got it in your yard, there's a good chance you've been fighting it. Here's what you didn't know you were throwing away. Mugwort's essential oil is dominated by a compound called 1.8 cineol. That's the same family of terpenes you find in eucalyptus. It also contains camphor. Together, these volatile compounds don't just smell strong, they disperse into the air around the plant continuously. That creates an invisible chemical field. Here's what researchers found when they tested these compounds on snakes. A US patent number 6689397, titled Identification of Snake Repellents, documents specific behavioral responses. Snakes exposed to camphor stopped moving entirely. Full behavioral inhibition just stopped. The cineol compounds caused an initial agitation response, followed by a prolonged, slow, investigatory behavior. Essentially, the snake withdrawing rather than advancing. The mechanism is chemoreception disruption. Snakes navigate by smell. They use a specialized organ to read chemical signals in the air. Mugwort's volatile terpenes interfere with that system directly. It's not a physical barrier. It's a chemical signal that says, move on. Your grandmother didn't know the word chemoreception. She just knew something felt different about that corner of the garden. And she trusted it. Now, a critical word of warning. Mugwort is invasive without hard containment. Its underground rhizomes spread aggressively. Do not plant it in open ground and walk away. You have two options. Grow it in a buried container at least 12 inches deep, or install a rhizome barrier 18 to 24 inches deep, 20 mil thickness minimum. Full sun, lean soil. Skip the fertilizer. It thrives on neglect. That's actually the point. One more thing about mugwort's history. It was called the mother of herbs in Anglo-Saxon tradition, part of a protective herb formula documented as far back as the 10th century. Planted at garden edges, not removed. That pattern shows up across cultures independently for a reason. Plant number 2, wormwood. If mugwort is the above-ground perimeter guard, wormwood wages war underground. Wormwood, Artemisia absinthium, is the plant behind absinthe. Silver-grey, feathery foliage, hardy in zones 3 through 8. Many countries banned it for decades because its chemistry is genuinely potent. That potency is exactly what makes it useful. The key compound is absinthin, a bitter alkaloid. Wormwood also produces thujone, a terpenoid in the same family as mugwort's terpenes. But here's what separates wormwood from most plants: its allelopathic activity. Allelopathy means a plant releases chemical compounds that suppress the growth of other plants nearby. What researchers found about wormwood's delivery system completely changed how I think about garden borders. It's not what you'd expect. Wormwood does this through its roots secreting absinthin directly into the soil. But that's only half the story. Researchers documented absinthin in the rainwater running off wormwood leaves. Rain as the delivery system. The plant doesn't need physical contact to exert chemical pressure. The water does the distribution work for it. That's elegant in a way that most engineered solutions aren't. Field studies show this allelopathic effect operates within roughly a 2-foot radius. The most sensitive plants, fennel, sage, caraway, anise, and most tender vegetables should stay well outside that zone. But drought-tolerant neighbors like lavender, yarrow, and ornamental grasses handle it fine. The practical setup give wormwood its own dedicated border zone. Between your garden and a wild area works well. Under fruit trees as a ground cover barrier works well. Just keep it 2 to 3 feet from anything you want to thrive. It doesn't need company. It prefers to work alone. Important disclaimer: wormwood is a garden plant. It is not an edible or medicinal herb for home use. The thujone content makes it genuinely hazardous if consumed. It was the reason absinthe was banned across most of Europe for over a century. Keep it in the garden. Do not make teas or tinctures from it. And critically, if you have dogs or cats, plant wormwood where they can't get to it. The same compounds that make it potent in the garden make it dangerous for pets to chew on. Same goes for mugwort. If pets roam your yard freely, both of these belong behind a barrier or in raised containers. Your grandmother would have known to keep the herb edge fenced off from the chickens. Same principle. That said, as a garden plant, it's one of the most low-maintenance perennials you can grow. Once established, it needs almost nothing. Lean soil, full sun, minimal water. It comes back every year, and year after year, that passive chemical dispersal through rainfall keeps happening whether you tend it or not. Your grandmother would have recognized this system immediately. Set it up once, let it run. Plant number 3, lemongrass. Both Artemisia plants operate through the same general family of aromatic chemistry. The next plant in your defense system works through a completely different mechanism. And I'll be honest, this one is my favorite, because it gives back in the kitchen too. Lemongrass, Cymbopogon citratus, grows 3 to 5 feet tall in dense, clumping stands. It's a tropical perennial, hardy year-round in zones 9 through 11. In colder climates, you grow it as an annual or bring it indoors before frost. The active compounds are citral, a blend of geraniol and neral, and geraniol. These are the same compounds that go into commercial insect repellents. Cornell University's New York State Integrated Pest Management Program documents citral as the principal biologically active agent in lemongrass essential oil. Demonstrated toxicity against mosquitoes, flies, beetles, and storage pests across multiple studies. Now about snakes. There is promising research suggesting citrus-scented compounds like citral trigger avoidance behavior in snakes, and some sources cite a study in the journal Toxicon. I want to be straight with you here. The snake repellency evidence for lemongrass is less definitive than what we have for the Artemisia compounds. Results vary significantly by snake species. What is solidly documented is lemongrass's effectiveness against insects, which indirectly reduces the prey activity that draws snakes into garden spaces in the first place. The practical setup: plant lemongrass in clusters of 3 along your south-facing border. Dense clumping creates both a physical and chemical barrier. And here's the part that makes it worth growing, regardless of any repellent properties. You can harvest the stalks for cooking. This plant earns its place in multiple ways. That feels like a fair deal. Plant number 4, marigold. Okay, this one genuinely got me when I first read the research. And this is the plant I teased at the beginning. The $2 nursery flower that's running a sophisticated underground operation. You know marigolds. Everyone does. Most gardeners think of them as cheerful flowers that maybe keep aphids away. That is a significant underestimate. French marigold, Tagetes patula, is running a sophisticated chemical operation in your soil right now. The weapon is alpha-terthional, a compound released by the plant's root exudates directly into the surrounding rhizosphere. In 2019, researchers publishing in Biology Open, a journal of the Company of Biologists, documented exactly how alpha-terthional works. It penetrates the outer layer of nematodes and induces oxidative stress. It disrupts key metabolic enzymes, including cholinesterase, the same enzyme targeted by some synthetic pesticides. The paper described alpha-terthional as one of the most toxic naturally occurring compounds found to date in the context of nematode control. One of the most toxic naturally occurring nematode killers in a marigold, the flower you buy for $2 at any hardware store. Wow. What are nematodes? They're microscopic roundworms that live in soil and attack plant roots. Root knot nematodes, Meloidogeny species, destroy tomatoes, peppers, and squash from underground. You don't see the damage until it's too late. The plant just fails to thrive. The roots are riddled with galls. You lose the whole season wondering what you did wrong when the problem was already there before you planted anything. Marigolds suppress them significantly. Not eliminate, suppress. University of Florida IFAS Extension recommends marigold as a cover crop specifically for nematode management before planting vegetable beds. California field research showed tomatoes planted after a marigold season had significantly lower root gall counts and higher yields. Here's the critical timing detail. The effect comes from living root exudates from actively growing plants. Marigolds need to be in the ground and growing for at least 2 months before you plant your vegetables. 3 to 4 months is better. Plant them where your vegetable beds will go. Let them grow out the whole season. The soil doesn't need to be turned over. The benefit is already in the rhizosphere. Optimal spacing 8 to 12 inches apart for maximum root exudate concentration. A dense marigold cover in monoculture outperforms scattered plants. And French marigold, specifically Tagetes patula, is the most researched variety for this purpose. One quick safety note on marigolds. They're considered non-toxic to dogs and cats by most veterinary sources. So, unlike the Artemisia plants, you don't have to fence these off. Pets and marigolds coexist fine. That's part of why this plant is the easiest entry point. Here's the thread that connects all 4 of these plants. They were all weeds at some point in someone's garden. Every one of them survived for centuries without care. And that survival in harsh conditions with no nutrients added, no irrigation, no pest control from outside required them to build systems. Chemical systems, allelopathic systems, phototoxic systems. Systems that most ornamentals bred for catalogue beauty simply do not have. There's something a little melancholy about how we lost this knowledge. Your grandmother probably didn't know the word allelopathic. She didn't know about alpha-terthenyl or 1.8 cineol, but she knew that certain plants at the edge of the garden meant fewer problems. She was running a systems-based garden. She just didn't have the vocabulary for it. We traded that knowledge for a clean aesthetic and a larger herbicide budget. The peer-reviewed science is now giving us the vocabulary to take it back. The irony is this: the plants we're taught to eliminate are often the ones that evolved specifically for our climate, our soil, and our pest pressure. A plant that thrives without your help has already proven it can handle your conditions. Its chemistry reflects that. A cultivated ornamental bred for showroom looks hasn't made those same trade-offs. Research across these 4 plants points to the same conclusion. Working with native plant chemistry produces measurable improvements in pest pressure and soil health at 0 ongoing input cost once established. If you're ready to start, pick one of these 4 plants and assign it a dedicated border spot, not in the middle of your beds, at the edge, in a container, or with a proper root barrier if needed. Starting from scratch, French marigolds are your safest entry point. Most controllable, most researched, immediately useful in any vegetable bed, and available at every nursery. Plant them this season before your tomatoes go in. Give them the full run of the bed, the 60 to 90 days. Then plant into that same soil. That's a direct, practical use of the chemistry your grandmother understood by observation. Now you understand the mechanism behind it. The difference between your garden and hers wasn't effort. She wasn't working harder. She was working with the plant biology, rather than against it. She didn't buy the plants that looked impressive in a catalogue. She kept the plants that proved themselves, and because those plants earned their place through millions of years of adaptation, they came loaded with chemistry that a catalogue plant simply doesn't carry. That's the real cost of the perfectly clean garden, not just the herbicide bill. The loss of that edge, the chemical layer that was doing quiet, consistent work along the border while everything inside it was protected. Which of these 4 plants are you adding first? Drop it in the comments. I read every one. And if this kind of evidence-based gardening is useful to you, subscribing keeps it coming. That's the deal.